critical numbers. C is a number, any number. For example, 2, 3, square root of 5, minus 10. Okay, C is called a critical number if the derivative of the function at C is equal to 0 or its derivative does not exist. I'm going to show you two examples here. In this example, this is the example of a graph that goes up and then it goes through a smooth highest point. At the highest point, the derivative is 0. So f prime of C is equal to 0. So whatever this number here is called a critical number. And this is a critical point. This is another graph. The function is not differentiable here. However, this is still a critical number. So whatever this number is, it's a critical number. So what does this mean? Suppose you own a company that makes your favorite gadget, like a phone, a cell phone. And then this is the equation of this graph here came from the equation of a profit. And the graph goes through this point. Well, here, this is a critical point because 1, the derivative is equal to 0. 2, you're maximizing your profit. So your profit is maximized when the derivative of the profit is equal to 0. So that's called a critical point, and then the number corresponding to it is a critical number. So what's that number? Okay, X could represent how many units you produce and sell. For example, how many phones do you produce and sell? C. Suppose the critical point is 1,990. So that tells you if you produce and sell 1,990 phones, that's a critical number. You're gonna maximize your profit. This is the idea of critical points. We're going to do some examples of critical points. For example, suppose you have this function here, f of x, I'm just making this up, okay, is equal to x squared minus 3x. And I'm going to call this example 201. And they ask you, what is the critical point of this function? You don't have to know what the function means. It could be the function of a profit, it could be your grade, it could be anything. But you want to know what is the critical number, if any, for this particular function. So what you do is you find the derivative f prime of x, which is 2x minus 3, and then you set it equal to 0. F prime of x equals 0. So that gives you 2x equals 3. Divide both sides by 2, and that gives you x equals 3 halves. X is C, the critical point. So C is equal to 3 halves. Our critical number here is 3 halves. And that's how you find critical numbers. We're going to do some more examples. Let's do this example. G of x equals minus x cubed plus 16x. This is also a function. Let us differentiate it. G prime of x equals minus 3x squared plus 16. And you set this equal to 0. So 3x squared equals 16. X squared equals 16 over 3. X equals square root of 16 over square root of 3. X equals minus square root of 16 over square root of 3. Square root of 16 is simplifiable, so that's 4 over root 3. And this one here is minus 4 over root 3. This one has two critical points. I wrote this before just to save time. F of x equals 3x squared e to the 4x. Okay, now we have two functions. This is a product of two functions. So to differentiate, we're going to use the product rule. So you write 3x squared times the derivative of e to the 4x, which is 4e to the 4x, plus 3 times 2x, which is the derivative of x squared, times this function, which is e to the 4x. 3x squared times 4 is 12x squared. 3 times 2x is 6x. So that's what you have next. And we need to set this equal to 0. Let us factor out what we can. We can factor out 6x e to the 4x. Take it out. 6x e to the 4x. 12x squared divided by 6x gives you 2x. And then 6x divided by 6x is 1. So 2x plus 1 equals 0. So either this factor equals 0 or this factor equals 0. So we're going to set 6x equals 0, e to the 4x equals 0, 2x plus 1 equals 0. I said either because there's only two of them. There's one that can't. Let's start with the mid part. This is an exponential. It can never equal 0, so that's out. So 6x equals 0 means x equals 0. That's a critical number. 2x plus 1 equals 0 means x equals negative a half. That's a critical number. So this function here has two critical numbers, x equals 0 and x equals minus a half. We didn't have issues of domain so far. Make sure that your critical number is in the domain. So far we haven't had. But we're going to pick an example where there's going to be an issue with the domain. In this example here, c of x equals x squared over x squared minus 16. This is a quotient, so we're going to differentiate it using the quotient rule. Let me remind you of the quotient rule. F over g prime is g f prime minus fg prime over g squared. G being x squared minus 16 and f being x squared. So it'll be x squared minus 16 g times f prime, the derivative of x squared, which is 2x, minus f, the numerator, x squared, times the derivative of the denominator, which is 2x minus 0, over denominator squared. We have 2x here and 2x here. Factor out 2x. 2x is out. That leaves you with x squared minus 16 minus x squared. X squared minus x squared will cancel. So that leaves you with minus 16. The 2x stays. And then x squared minus 16 squared. When you're doing critical points, there is an issue with domain here. Here, the denominator can't equal 0. So that means x squared minus 16 can't equal 0. X squared minus 16 cannot equal 0. Now that means x squared, x minus 4, x plus 4 cannot equal 0. So x cannot equal 4 and x cannot equal minus 4. So these can't be critical points because they're not even in the domain. So let's see. Now for critical points, you're supposed to set the derivative equal to 0. This is the derivative, set this equal to 0. When a fraction equals 0, only the numerator has to equal 0. So 2x times negative 16 equals 0. That means x is 0. So the critical number is x equals 0. And the critical point is the point corresponding to it, which you can get by substituting x back in the original function. 0 here, 0 here, so that gives you 0 over 0 minus 16, which is 0. So the point is the origin, but the critical number is x equals 0. 205.